In exam, I asked one question to you people. That question was very simple, and all of you almost answered, except few. That determine the point of regression for 3 points, 3 possible points. You answered in different way. I appreciate. This is just for making it okay, for clearing the theme. I asked determine okay some kind of a line or linear regression for these points. So what you need to do? You need to basically, there are 2 points okay between x-axis and y-axis. So there are total 3 points, and technically you need to follow some kind of equation of line, or you can say this is the benchmark, or for hypothesis parameter you should follow some kind of okay like this. And here it can be okay more point theta 1 theta 2 plus x2 like this, but here only we can say like this one, okay, the first one, the second one. Why? This is the point P naught, P1, P2. So the connection between point P naught to P1 is measured with the help of theta naught. You need to consider weight parameter from P naught to P1, and from P1 to P2 the weight parameter is the theta 1. Are you getting my point? So technically what you need to know, you need to determine here this one, this equation, or may I ask you, you need to determine this theta naught and theta 1. You did the same way, just okay for making it more clear. So we can consider the cost function concept, J, okay, weight parameter. Of course there are 3 points, in denominator you can write 1, 2, 3. Yeah, kind of a, I am mentioning here n factorial, or kind of a 3 factorial. Okay, because we are talking about the 3 points, 1, 2, 3. You don't worry about it. It's a mathematical okay trick. But of course, 1, 2, 3, and you can write in any way. The hypothesis first, or this value at the second. So example along y-axis. So here, of course, it is kind of a scale. Loss function. You need to determine kind of a scale. A moment ago we studied, discussed. Determine the difference, okay, between the observed or the predicted value, or given or the predicted value. So this, because there is a scale, so it does not matter. You can write it at first place or the second place. Is that clear? And you know, this is equivalent to
theta 1, theta naught.
You can theta naught plus theta 1 x1. And we know there is x sub 0, okay? We know, but it is equivalent to 1. We are ignoring it. Okay, so, and how many weight parameters are there? 2. So, J, theta naught, theta 1. You need to apply partial derivative. A moment ago we studied that the loss function with the help of partial derivative. So with the help of partial derivative, what you need to know? You need to know theta naught. Similarly, you need to determine
Theta 1.
theta 1. If I am talking about the first, then what you will do? You need to minimize it. Minimize at such a level, you need to consider it almost negligible. Then negligible mean you need to consider it equivalent to 0. Okay? minimal. Did you remember?
Mini.
Yeah, this is the thing. Or you need to approach it this equivalent to 0, this equivalent to 0. Then you will determine the value of theta naught kind of things. So here, first you remember this formulae, okay, you need to substitute the value of this. In case we are considering,
So theta 1 also 0 because theta 1 has this x1.
no, this is another case. Let me explain please. This is another scenario. So you are applying here this is, okay, you want to say this one? Yes, this is. I mentioned here, not nobody. Scale. When you will, okay, this side of course you consider equivalent to 0. But you need to of course the first one partial derivative with respect to theta naught. Then this two terms, scale term, this scale term comes here, then you will get 2, 1, 2, 3. This will, okay, cancel out. Even the remaining terms will go this side. All terms will be vanished out. So you should not worry. Even if we do not consider this here, then this 2 will, but this looks a little bit awkward. So for mathematical beauty, we consider this normalization term and we cancel out the remaining term are 0. If we do not have these 1 over 2, 3, then again this, if we divide to both sides, then of course it will be vanished out. Is it clear?
Yes, sir.
So it's not a big deal. So now this one we will have summation y for okay 3. We need to sum up all the 3 points of a y. Then of course we are considering the partial derivative with respect to this term. Then
x0 should also
this is the inner term, okay? This is the inner term. You should consider this as it is. Okay, according to power rule, 1, 2 minus 1 equal to 1, so here is 1. Is it clear?
Yes, sir. Yes, sir.
So inner side, you should not consider this term because we are considering the partial derivative with respect to theta. This will become 0 and this will become what? X naught. X sub naught. Here, if you are considering the partial derivative of theta naught, x naught with respect to theta naught, then okay, this one answer is what? Only x naught. This will be cancelled out. Is it clear?
Yes, sir.
And we know x sub 0 equivalent to 1. So just ignore it. Just ignore it. Is it okay?
Yes, sir.
Now we can write this. Other terms, okay, we will Is there any objection?
No, sir.
I think it's good. Now we need to sum up the 3 points of a y. 3 points of y, 1 plus 1,
Plus
4 equivalent to 6. Or you can say here, I am writing here, equivalent to 6. Is it okay? You know, if we are talking about this value of this value, this is equivalent. Now this is somehow, please consider, I'm begging, okay, for kind attention. This term, this theta naught is unknown parameter for us, okay. So you should consider basically this index. Example are 3 for the feature values, no index for the theta, okay. So theta naught here, so you will have this one for here. Is it clear? My children, you know what is the value of x sub naught?
1.
1. So there are, how many examples are there? 3. So I mean to say, how many points are there?
3.
3. So 1 plus 1 plus
1.
answer is
3.
3. So you will write 3 theta naught. Okay? Is it clear, please? Now this one, x1 are kind of a y1, okay. You need to follow the point of given points, but remember each point is representing one value, x1, x1, x1. x1, x1, x1. Or you can say there we have 3 points, x1, y1, x1, y. Though we say the point 1, 1, 2, 3, like, but there are 3 variations, okay. So we need to sum up. Now you will have this output kind of things, 5 theta 1. And you know this equivalent to what? 6.
6.
This is your equation. Yes. Now proceed, talk about, now we need to differentiate, okay, partial derivative with respect to theta 1. Of the same, if you will differentiate this with respect to theta 1, then the scenario will be changed again. In this situation, what will happen? You will consider the terms, okay, this is the whole term, square terms, because involve theta 1. This whole term we will get again. But again, you need to take the inner, okay, derivative of this. This will become 0, okay, theta naught, we do not consider it. But here, x1 is not equivalent to 1. So you will again get x1. And at this, okay, so here, let me know. 3 and minus theta naught. I will not write x naught again, okay? We know it's equivalent to 1 plus theta 1 x1. Okay, so here it's equivalent to 2 and again this equivalent to 1. Why? Because we are differentiating with the partial derivative with respect to x1. So answer of this is look like, okay, again these all terms will be vanished out and you will get x1, this, okay, y term minus theta naught x1 plus theta 1 x1 square. Remember this is scale, okay? I is representing some kind of example, but this is scale value. So here okay, sorry, here negative sign. So it will, because, so we can write it further like x1 equivalent to theta naught x1, theta naught x1 plus, now, okay, I shifted right on the side, theta 1 x1 square. Again, here at this scenario, what you need to do, you need, basically if there is no value given, we know it's equivalent to 1. Okay, so you need to get the product of all the values of x and y, then you need to sum up. How? You need to multiply 0 and 1 become 0. Okay, if you will multiply this way, okay, 0 and 1 become 0, 2 and 1 become 2, and 3 and 4 become 12. So 12, 2, 0 equivalent to 14. So you are this, okay, equivalent to 14. Again, if you are considering the scale x, because somewhere we need to consider the x1 scale, 0, 0 scale 0, 2, 2 scale 4, 3, 3 scale 9. So 9, 4, 0 equivalent to 13. Remaining we know. This is the sum. Okay? So we need to substitute there. So what is the answer here? 14. What is the, we know, what's this answer?
5.
5 theta naught plus this, what's the answer of this? 13 theta 1. This is your
Equation B.
Yeah, you can say it's B. With the help of A and B, okay, you can extract the value of theta naught and theta 1 from A and B, okay. You remember, okay, 6,
6, 3, 5. 6, 3, 5.
what the 5 theta?
5 theta naught plus 13 theta.
So answer is kind of I already calculated it somewhere. So you get theta naught 4/7, theta 1 6/7. So your hypothesis function, you can say it's equivalent to the, okay, theta naught plus theta 1 x1 equivalent to 4/7 plus 6/7. Once you will get, okay, sorry, this one, some kind of, this one, but you can substitute the value somewhere there, okay, for its iteration parameter. Okay, the concept of this further will be utilized in the sigmoid function. Let me explain how it will work there in the probability equation. You know, your sigmoid function basically equivalent to of okay, if we say g of z, here this one is what, so you say equivalent to z, and you can say 1/1 plus e minus z. This is okay, just instead of I make it simple. So you need to this is what? This is some kind of sigmoid function, and in terms of probability, or let me write it like 1 over. I can also write this exponent minus. You should not worry. If you will see in your sum of textbook or somewhere this, it's the same. Okay? So in our probability case or our final decision system for y given value such that 1, it can be parameterized with respect to the weight parameter. Okay, in your probability, this product is basically probability telling us some kind of a replica of summation, and this will, for m number of examples, you can say it can be written like 1 over 1 plus minus theta tau x, and again here product. Once you will write, you will subtract this term from 1 minus this, then you will in the denominator you can write, keep the, okay, this expressions in a similar fashion. What I did, basically I said if you have 1 minus 1 over x, it can be written as x, no, okay, sorry, 1 plus x, you will write it like x
over 1 plus x.
1 plus x. Okay? Here, this is, I am talking about the malignant, dangerous case, if noticeable case. If the 0 is another case, I'll explain it in a moment. Or you can say simply, this is the scenario. Once you will have y, example I like are 1 minus y I here. Just for a moment here consider it is, you may consider simple value of this. Okay.
Sir, this equation is in mistake because it is not satisfied this criteria.
Which one, please?
First one.
This one?
Yes.
No, if you multiply this here, 1 plus.
No, sir. This first one.
First one?
Yes, sir.
Yeah, I'll explain that. Okay, mistake. This, for example, if you want to predict for the value of y once it's equivalent to 1, what you will do, you will consider y equal to 1 here, then 1 minus 1 becomes what? 0, and here what? 1 negligible, you will get only this term. Okay? Once you will, you are talking about the benign case, your y will be what? 0? Y equal to 0, this y will become 0. Here 0, this whole term becomes 1. And here 0, this will become this case. Are you getting my point or not?
Sir, how do you transfer first to second one?
I said that these both are the product. How I transferred first to second?
Yes, sir.
1 minus 1 over 1 plus so consider the common multiple of both of 2.
This first one is not like this.
Yeah, this I am telling you that this is a trick. This is a trick. Okay, here First one is a simple one, only with y. Here 1 minus y. That is the 1. So 1 minus y. Are you getting my point?
Okay, sir.
This one, my son, this is the, okay, that's why after calculation you get the same result. Is it clear, please? So, now you got that your probability gives you some kind of a binary result, decision, 0 or 1. By keeping the convergence criteria inside of it, and with simple, okay, in my last lecture I already explained the theme. So, in this point formula, in this situation, basically these are the points and you are getting some kind of a graph. Let me explain this is a kind of a graph, and you are having points like first is 0, 1, second point is 2, 1, and third one is 3, 4. So you are talking about like this. Once your x-axis is 0, you are talking about this. Your y is at 1. Okay, or you can say simply the kind of a scale like this. Or you can say difference, gap. This is the point should be here, but it is somewhere there. This is a difference. Once you are talking about the second one, one x-axis is 2 at this point. Your y-axis is what?
1.
Y-axis is 1. So you get y-axis, right? Okay, because this is the first one. So this is the scale. Everywhere you notice I am talking about the scale difference. Scale difference. So once you are talking about the third, now there is again a scale, but this scale should be not beneath of the line. It is above of the line, and where at the 1, 2, 3, 4. So somewhere, you can say it's a big scale. The scale again, everywhere scale, your least square formulae. Basically, you need to reduce the size of the scale. Are you getting my point? So that the system, these points should exactly align to this linear regression, this linear line, this line. Once you will shrink the size of a scale in order to meet exactly at this, then what will happen? Loss. Okay? Value will be square, many values will be come, somehow you can say shrink. This square size will be lost. So loss function. By doing this, what we do, actually we are attaining the convergence. Are you getting my point? No, not?
No.
Okay, so there is a same, for example, this one is the error, Your output, with the help of your experiment, you get this one.
Yes.
But the actual benchmark, say this one. The gap is there or not?
Error.
There. What you need to do? You need to
Minimize.
minimize, minimize this gap, this difference. Once you will minimize this gap, you will lose something, of course.
Because.
Then, of course, your target is to reach at this point. This point. Technically, it's kind of, we are talking about the scale, basically it's the scale. Each point is kind of a scale, representing some kind of a scale value. So we are reducing the scale.
Minimize.
Minimize, okay? Minimize the scale so that it should shrink and exactly, okay, at this point. Size of the scale should be reduced.
Why we minimize?
Because if the gap is too, okay, for example, road is, okay, you are here and your transport is moving on a roadside. So, in order to your easiness, the distance should be reduced or not? Reduced. So, this is the thing. You make the things simplest and making it easy for yourself. So your automatic system can work nicely, smoothly, so that you can easily jump into your required transport. When? Okay, otherwise, if there is no time, shortage of time, you are in a hurry, okay, you are in trouble. You cannot jump from here to there. Is it okay? So, in order to reach there, you need to apply the convergence criteria. Gradients, okay? Manageable steps change. So, you will reach there with the help of gradient descent approach.